Section 7.2 is on solving exponential equations and inequalities. An exponential equation or inequality is an equation or an inequality in which the exponents are variables. So most of the time, remember, we would have something like x to the second power, x squared. In that case, x is my base, and my exponent is a number. With an exponential equation or inequality, my base is going to be a number, so for example 2, and my exponent will be a variable such as x. So here's the way we're going to do this. So if b raised to the x power is equal to b raised to the y power, then x equals y. In other words, if my two bases are the same, then my exponents are going to be equal to each other. The same thing is also true with an inequality if you have a less than or a greater than sign. If b to the x is less than b to the y, notice my bases are the same, then I can just pull off the exponents and say x is less than y. So let's take a look at several examples here. So number 1 here says solve this equation. So I have 4 raised to the power of 2x minus 1, and that equals 64. Remember, solving means finding the value of x that makes this true. So the key, what I'd really like to do here, is rewrite each side of the equation with the same base. So in other words, some number raised to a power equals the same number raised to another power. So looking at 4 and looking at 64, I realized that I can write each of those bases, each of those numbers, with as a power of 2. So 4 is 2 squared, and that's going to be raised to the 2x minus 1 power. Notice just instead of 4 I wrote 2 squared, and 64 is actually 2 to the 6th power. Now how are you going to figure out which numbers to use as your bases? To be honest, most of the time it's going to be 2 or 3 or 5. Sometimes it can be 6, some smaller number. And you just kind of have to try a couple different things. And after you do several problems, you'll get used to what you're supposed to be looking for. Okay, now that I have this equation written with the same base, now I can just solve it, but I have a little step I need to do first. This 2 inside the parentheses needs to be multiplied by the 2x minus 1 outside the parentheses. So this is 2 to the 4x minus 2 power, which equals 2 to the 6th. And now that I have exactly the same base and no parentheses, I can just pull off the exponents and make those equal to each other. And now it's just a very straightforward equation to solve for x. So x is equal to 2. And you can even go back and check this. Plug that back in there. Is 4 raised to the power of 2 times 2 minus 1, so that'd be 4 raised to the power of 4 minus 1, or 4 to the 3rd power. Is 4 to the 3rd power equal to 64? Indeed it is, so it does work. Here's our second example. 1/2 raised to the power of 4x plus 1 equals 8 raised to the power of 2x plus 1. Now remember that a fraction can be written as the denominator raised to the power of -1. Remember, a negative exponent means you put it in the denominator. So 1/2 is actually 2 to the -1 power. So I'm going to start by doing that. So this is 2 to the -1. That's my 1/2 that's in parentheses, to the 4x plus 1. And I need to write 8 with the same base, a base of 2. 8 is actually 2 to the 3rd, and that's going to be raised to the 2x plus 1 power. So 8 is 2 to the 3rd, 1/2 is 2 to the -1. Now let's multiply and get rid of the parentheses. So -1 times 4x minus 1 is going to be, I'll write it as the base, 2 to the -4x minus 1 power. And now multiplying 3 times 2x minus 1, 2 to the 6x plus 3 power. Now I have my equation written with the same base of 2, so I can just pull off my exponents, set those equal to each other, and now I have a pretty straightforward equation to solve. Adding 4x to both sides and subtracting 3 from both sides, and then dividing by both sides by 10. I get that x equals -2/5, And to be honest, this looks a little messy to plug back in and try to do in my head. I would probably do that in the calculator. Check this in the calculator by plugging in -2/5 for x. And we can do the same thing with inequalities. So here we have 5 raised to the power of x plus 8, and that is less than or equal to 265. Okay? In this case, my base is going to be 5, because I can write 265 as 5 to the 4th power. Okay? And if you're not sure, okay, clearly 625 is divisible by 5, so I'm just going to try a couple different things, 5 squared, 5 to the 3rd, 5 to the 4th, 5 to the 5th. Just keep trying a couple different things in your calculator until you get what it is. So this is going to be 5 to the x plus 8. So now I can just pull off my exponents because I have the same base. X plus 8 is less than or equal to 4, and subtracting 8 from both sides, x is less than or equal to -4. And again, you can go and check this by plugging in -4. 5 to the 4th is indeed less than or equal to, in this case, it's actually equal to 625. And our last example, 1/9 raised to the power of 3x plus 5 is greater than or equal to 1/243 raised to the x minus 6 power. Well, 9 kind of jumps out at me and says that that's 3 squared. So 1/9 is going to be 3 to the -2 power, because 1/9, let me do it over here, is equal to 1/3 squared. If I want to move that exponent up to the top, I make it negative. So 1/9 is 3 to the -2 raised to the power of 3x plus 5 is less than or equal to. Now I need to figure out, can I write 243 as 3 raised to some power? So grab your calculator. You know what 3 squared is, 3 to the 3rd, 3 to the 4th, 3 to the 5th. Just keep trying until you get what 243 is. So 243 is actually 3 to the 5th power. Okay, so 1/243 is 1/3 to the 5th, which is equal to 3 to the -5th power. So I'm going to rewrite this as 3 to the -5th times x minus 6. Let's get rid of those parentheses. Multiply the exponent inside times the expression outside. So this is going to be 3 to the -6x minus 10, which is greater than or equal to 3 to the -5x plus 30. And I just multiplied the exponent inside with the expression that was in the exponent outside. Now I have exactly the same base of 3. Pull off the exponents and write the inequality. And let's solve. I'm going to add 5x to both sides. So that leaves me a -x minus 10 is greater than or equal to 30. Adding 10 to both sides. -x is greater than or equal to 40. And now I need to divide by a -1. And don't forget that when we multiply or divide an inequality by a negative number, we have to flip the direction of the inequality. So this is going to give me a positive x, but my greater than or equal to is going to turn into a less than or equal to -40. And again, you can check this if you'd like by plugging it into the calculator. It's going to get a little messy, and I don't think I can do that in my head. But that's how you would solve an exponential inequality. Just make sure that whenever you're dealing with inequalities, you remember to flip the direction of your inequality sign if you multiply or divide by a negative.